Today I want to show you a mathematical problem which I invented totally by myself because one day I bought a speedometer. You can see there's a speedometer to measure how fast is my bike moving. And I realized that the speed measurement was a little inaccurate, and hence I invented this problem. So please read it. You can read it in English here, and below you can read it in Chinese. A bicycle wheel has a diameter of 66 centimeters. Okay, so this is bicycle wheel, and this is the diameter. I'm drawing diameter now. This is 26 inch, but for the calculation I converted inches into centimeters. So as you can see, the diameter is 66 centimeters, which means that the radius is half of the diameter. So radius is 33 centimeters. Okay, that's the information we have. However, the magnet for the speedometer, you see the magnet, because the speedometers, they have a digital face like this one, and they have also a magnet which is placed on the wheel. So the magnet is placed 25 centimeters from the center of the wheel. So magnet is not exactly at the end, it's not here, but magnet is placed maybe here. So yeah, over there. So the magnet is placed 25 centimeters from the center of the wheel, not on the rim. This is the rim. While riding, the bicycle speedometer shows speed of 12 kilometers an hour. The question, what is the cyclist's actual speed? So the speed is not 12 kilometers an hour, although it shows 12 kilometers an hour, because it's measuring the speed according to this smaller circle radius. But the real wheel is bigger, so the speed should be faster than that, because we placed the magnet in this area. Therefore, the speed is according to that small wheel. So that when you set up your digital speedometer on the bicycle, it's very important to enter the diameter of the wheel according to the wheel you have. If you make a mistake, then you need to recalculate it. That's what we are doing now. So how are they to solve this equation? Not to solve this problem, we need to know, first of all, I will calculate the total length, the total circumference of the circle. We need to know the circumference. And you remember this wheel is like a circle. This is a circle. So wheel, Lunze in Chinese probably. Wheel is 2 pi. Wheel circumference is 2 pi times r. R is radius. 2 pi times r. So it's gonna be for big circle and small circle. So for small circle is 2 pi times 25 centimeters, because small radius, this radius is 25 centimeters, so it's gonna be around, I converted it to meters, it's gonna be 1.57 meter. That's the circumference of the small wheel. Of this small wheel, circumference, if you go around, is 1.57 meter. Now circumference of the big wheel is again 2 pi times r, but here is not 25, it will be times 33 centimeters, and it's gonna be 2.07 meter in approximation. 2.07 meter. That's what we need for our calculation. So we know the D1 equals 1.57 meter, D2 equals 2.07 meter. So D1 is diameter of a small circle, small here, which is created by the magnet, this magnet, and D2 is diameter of the big circle, the whole wheel of the bike. And why do we need it? Because now we can divide. Why I want, I didn't know any formula. I solved it using my common sense. So I divided 12 kilometers divided by because the speed. is 12 kilometers, which means that in 1 hour the bicycle is doing 12 kilometers. I divided it by 1.57 to count the number of revolutions. Yeah, to count the number of revolutions. What is revolutions? I don't mean overthrowing system. Revolution in physics and math means total time when the wheel is going around and coming back to the same position. So for example, one full revolution, you start here and you make 360 degrees around. That is called revolution. So we will convert, for better calculation, we'll convert this 12 kilometers to meters. So you have 12,000 meters divided by 1.57 meter equals 7,643. It means that when bicycle travels 12 kilometers, the wheel will do 7,600 revolution. It will turn around 360 degrees 7,643 times. And this is constant. It's the same for the small circle, and these revolutions are the same for the big circle. That's why in order to know what is the real speed, what is the actual speed, we just need to multiply this number of revolution times the big diameter, and it will convert the speed. So what we needed to know just to count the number of revolutions, and we counted it by dividing the distance by the circumference. Okay, so let's solve it. We're gonna now multiply 7,643 times 207. It will give you approximately 15.8 kilometers an hour. So that is the actual speed. So you can see the speedometer showed 12, but actually the bike is moving much faster, 15.8 kilometers. That's why it's very important to place your magnet. Yes, place your magnet, this one, in the right position, closest to the rim. If you put it somewhere there, then you need to calibrate your speedometer, enter the smaller diameter than actually you will. Otherwise, your speed will be shown inaccurately. Okay, I hope you find this video useful. Thanks for watching. See you in the next one.